Okay, well, welcome to the productivity tips for the C# IDE talk. Oh, you guys just all went dark. My name's Anson Horton. I'm a program manager for the C# IDE team. And when we were talking about sessions for the PDC, one of the things that came up was this idea of the lunch sessions. In the general format, the idea is meant to be that you guys could come in and leave at any particular time and still get something out of the session. Now, the funny thing is when I was thinking about particularly the tips and tricks for the C# IDE session, it occurred to me about the usability labs at Microsoft. And it's kind of funny, the usability labs at Microsoft, they remind me a lot of like a NYPD Blue or Law & Order episode. It's actually like a one-way mirror. So you get back behind the one-way mirror and the usability participant comes into this white-walled room where there's a single computer set up with a camera in the back. And they start typing away. And occasionally a voice will come down and say, how does that make you feel? And and it goes pretty well. But the interesting thing is, while we're watching people use the product, a lot of times, we're in the back and we're just like, oh, just click there. And it'll be much faster, and you'll get the task done just that much more quickly. And so this presentation is really all the things I would have been told the usability participant if I could have just gone through the glass and told them. So let's go ahead and get started. So this is the agenda. And this is an agenda we've been using for a lot of the IDE presentations really recently. It's a lot like an application lifecycle that you might get if you're asked to add a new feature to an existing code base that you're not familiar with. So probably the first thing you do is you spend a bunch of time trying to understand the code. And after you understand it, you probably have to modify it a bit before you could add your feature so that it can fit in sort of a natural way. After you do that, you're going to obviously spend some time actually writing the feature that you want to add. And finally, unless you've written it sort of correctly the first time, spend a bit of time debugging it. So this is generally, we're going to see some tips and tricks in each of these sections. And I'm actually happy to say that that's basically the last slide that isn't a demo. All right, so let's move over here to Visual Studio. So the first thing I'm going to do is I'm just going to run the application, because that's probably the first thing you would do if you were trying to understand code. This is an application we've used in a lot of demos over time over the PDCs. Actually, the first time we showed it, it was in the 2000 PDC as the very first C# demo. So some of you may be familiar with it. The idea is it's a Quake model viewer. So it's just, if you guys are familiar with first-person 3D shooters, the idea is that we can load basically the enemies or the players themselves and render them on the screen. And we can see it's just a general win form, and I can rotate the guy and look at him. All Quake models come with sort of these sequences that you can set, animation frames, and I can play through those, and you can see that he moves around, and I can view him as a mapped view as well. So I could look at it like that. So it turns out that the application isn't particularly important. I just want to give you guys an idea of what it looked like. So the first tip that I'm going to give is actually less of a tip and more of just a general guidance, and that's if you're given a new code base, you might want to really get a high-level understanding of what that code base does. And a really good way to go about that is by using the class designer. So in order to use the class designer in 2005, what I can do is I can go to Add New Item. Now, the nice thing about the Add New Item dialog, and this is new in 2005 as well, is that it's much more like an Explorer window now. And I can actually just type the entire name of the thing that I want to get into and just hit class diagram. It used to be that the first letter would jump it around a lot. Now it's much faster. So at this point, when I create the class diagram, what it's doing is it's going off in the back, it's creating a design surface for me. And then it tells me that I could basically drag shapes over from either Class View or Solution Explorer to use this. So I could just click on this thing to open up Class View and then use that as sort of my entry point into the diagram. But since it's a tips and tricks presentation, I'm going to talk a bit about keyboard bindings. Now, when I talk about keyboard bindings in this talk, I'm really talking about the keyboard bindings that are set when you choose the Visual C# IDE settings. So a lot of times when Visual Studio initially starts up for the first time that you use it in 2005, you have this choice of different settings that you can pick. You can pick like the Visual Basic settings, the General Development settings. Each of those contains a set of keyboard bindings. Each of them have a set that are the same, but others that are different. If you choose the C# ones, that you get a sort of consistent set of themed keyboard bindings. And I'll talk about those ones in this presentation. So let's highlight Solution Explorer instead. And then let's use Control-W-C, which is the keyboard command to get to Class View. And in fact, all of the windows have a Control-W as their first chord in the key. So it's sort of a quick way to navigate in between windows. I'm going to just expand some of these things in Class View and scroll through it. just to look down and see if there's maybe something interesting that I could see here. And of course, I know this is a model viewer, so model is maybe a particularly interesting class to look at. So you can see I can just drag that over to the class diagram. I get this visual representation of what the class looks like. There's a little chevron up in the corner here that I can expand, and I can see members and fields and such. And I can look through that and get an understanding of what this particular class does. But the class diagram is actually much better at sort of giving you relationships between classes, particularly inheritance relationships. So what I can do on this is I can say, right-click it, and I can say, show me your base class. And I can get sort of another visual representation of the relationship there. And in this case, it's an abstract class, so it actually has a dotted outline. Now, I could dig in a bit more about how you could go through this and really get a good understanding of the class, but instead what I'm going to talk about is a trick that if you don't use the class diagram very often, or even if you do, you may not know. And that's the class diagram can view not only your own code, but sort of metadata as well. And so if you look in class view, there's this new node called project references. This is new in 2005. If it doesn't show, there's an option up here that actually controls whether or not to show this node. So if you don't see it, then you should enable this option. But what you can do is you can expand this. You see just the references that I have in general for my project. What I'm going to do is I'm going to find the system.io namespace and drag that on to the class diagram. Now, this is interesting. So what's going on now is when I drag it onto the class diagram, it's actually going to iterate through all the types in the system.io namespace and create me a layout that allows me to quickly sort of see the structure of that entire namespace. And so if we make this a little bit bigger, we can see one of the questions that we get asked a lot is, if you're new to a framework, you may see that a lot of the methods take stream, for example. Well, a lot of the questions we get are, okay, well, stream's abstract, so what are the concrete implementations of stream? It turns out this is a really good way to find out that kind of information, because we can see here that basically we have 4 different kinds of streams in system.io that are the concrete representations. And so this is a really good way if you have metadata, you get a third-party control library, or if you're just exploring a new part of the framework, this is a really good way to sort of get that understanding and see those relationships. So that's what I'm going to talk about for Class Designer. Let's dig in a little bit more to how you might understand code that actually is in your project. So one of the things I want to do is I want to go to Class View. There's a new search pane at the top of Class View that allows, you can type in and sort of filter Class View down to just the things you're typing in. And I want to find the main method, because I know that all C# applications sort of start with the main method. So I'm just going to type it in, and I can just hit Enter really quickly to sort of jump there. And I can see here it does exactly what I would expect a normal WinForm application to do. It creates a new form. And so I want to find out more information about this form. Well, so the way you may know about this, and hopefully you do, there's a command called go to definition. It's off the right-click menu. The keyboard binding for go to definition in 2003 and in 2005 is F12. So I'm going to use that. And when you use it, you're taken to the declaration. Now, what I can do here is I can kind of scroll down through this code. I can get a view of the fields that are in it, and I can get an idea of the methods that are in here as well. There's a lot of fields. But this is maybe not a particularly efficient way to really get a high-level understanding of the class, because you can't really see necessarily all the members in a more concise way. So I could go back to the class diagram. I could look there. I could try to filter down class view and look at this type in class view to see that. But it'd be really nice if I could do that directly from the editor. So we have a command called collapse the definitions. And collapse the definitions, the keyboard binding is Control-M, Control-O. So what you do here is I'm just going to hit that keyboard binding. And you can see what happens is we just collapse down all the regions. So you get this really nice header-like view. So it's pretty quick to be able to sort of go through here and then find a particular method that might be interesting. Now, when you get to a method that is interesting, of course, the next thing you're going to want to do is expand that particular section and dig into that a little bit. So we have another keyboard binding, which is toggle region, which you enable by hitting Control-M, Control-M. And when I do that, it doesn't toggle all the regions. It toggles only the region that you're sort of currently active on. So you can see if I scroll down a little bit that all the other regions remain collapsed. Now, Control-M is a toggle, so I can hit it again and collapse it. So it's just a really quick way to sort of expand and collapse regions and look through them. Now, open file is a particularly interesting method in this program, because we saw that after I opened the file, that's when everything started executing. So it's probably one I want to spend a little time just looking at. Now, it's a bunch of confusing code. It basically sets the wait cursor, and then we scroll down a little bit, and we see that there's this load from file method, Well, that one sounds kind of interesting. This is the part where it's actually loading the thing off disk, so we want to take a look at that. So again, we're going to hit F12 in order to do go to definition. And we go to definition on load from file, and then we can take a look through it. We can see that it's creating new MDL files, and then depending on the version that the model file's in, it's doing different things. So at some point, after we've dug into that a bit, we're going to be at the point where, okay, we're going to want to pop up in the stack, right? We've gone to definition, now we want to go back. So this is a key binding that's actually available in 2003 and in 2005. And actually, not a lot of people know it. It turns out that in Visual Studio, there's actually two main navigation stacks. There's a navigation stack that's particularly visible. It's visible up here on the toolbar. And it's Control minus and Control Shift minus. Control minus is backward. This is actually an editor heuristic. So this works based on sort of the cursor location and where the last place you made an edit was. But it has no real relationship to go to definition. So what can happen is if you're using this particular navigation stack when you're using go to definition, a lot of times you might scroll up and down within the same file before you actually go back to the place where you invoke go to definition from. So instead, there's a second navigation stack. And you invoke that navigation stack with the key bindings Control asterisk and Control ampersand. Control asterisk works in 2003 as well. So what you can do is I'm just going to hit Control asterisk here. And you see I'm taken back to the place where I originally invoked go to definition from. So this is a really good way to make sure that you you can sort of use this virtual call stack. You can like walk down the call stack and then you can pop back up. It's a good way to go in depth in methods. And again, I can use Control ampersand to sort of go forward. So I can go back and forward with this with these commands. So that's half of the story. That's the go to definition story. That's the idea that you're from a reference and you want to see how it's declared. There's another half. And that other half is the idea that, well, you're either at the declaration, you're at a reference, you want to know about all the other references. This one's kind of a funny thing that we did in 2003 is we have a command called go to reference. But a lot of people told us, hey, that doesn't make a lot of sense. In go to definition makes sense, probably one definition. But for references, there's many references. What does it mean to go to a reference? It turns out what it means is that we pick one at random. Now, what many people don't know, though, is that you can subsequently iterate through the rest of those references in 2003. And you probably don't know that because we didn't make it particularly discoverable. But in 2003, if you hit Control-Shift-1 and Control-Shift-2, that means go to the next reference and go to the previous reference. That's a good tip for 2003. Now, in 2005, we decided that that was such a common operation, we better do a better job. So now we have what we call find all references, which is more logical. And you invoke that by hitting Shift F12. So that makes a lot of sense because F12 is go to definition, so the opposite of that is find all references. And what happens when you do that, and I just did it on load from file, what happens when you do that is we pop up a window that's a list of all of the references for this particular thing. Now, there's a bunch of advantages over what we have in 2003. First of all, it tells you how many matches there are, so you know how many references there are. You get a list, so you can do sort of nonlinear searches. And, it looks nicer. So the next question that people have a lot of times is, what if I do want to iterate through all these? And there's a really very useful key binding that if you don't know, it's going to save you a lot of time. It's F8. And so what you can do is I can hit F8 here, and what's going to do is, even though my activation is in the editor pane, it's going to move me through this list. And in fact, if I hit it a bunch of times, you'll see that it's also cyclical. So when it gets to the end of the list, it starts again. Now, this key binding is useful for final references. It turns out it works for any list window in 2005, and in fact in 2003. So whether you're talking about the task list, the error list, so if you build and have errors, you can use this key binding to iterate through them and fix them. It's a really useful key binding. So that's what I wanted to show about understanding code. Let's just go back to slides really briefly and sort of review what we talked about. We talked a bunch about the navigation stuff. The two different types of the navigation stacks, the one that's very similar to the Internet Explorer one, and then the one that's specific to go to definition. That's the one that's the Control asterisk and Control ampersand. We talked about collapse to definitions. That's the Control M, Control O, and the toggle, which is Control M, Control M. What we didn't mention, or what I'm going to mention now, is extended mouse button support. So it turns out that the navigation stack that we have for go to definition actually is mapped to, if you have an Explorer mouse, the navigate forward and navigate back. So you can really navigate just with the mouse if you happen to be, looking at code and scrolling using the mouse wheel and such. And the final thing is we talked about final reference, how that's different than go to references in 2003 and how it's bound to Shift F12. And we also talked about a little bit about the class designer. In particular, the tip there was that It's a really good way if you want to find out about metadata to drag over the namespace that the metadata is in. You'll see all the types and be able to see their relationships. Okay, so the second thing I want to show is modifying code. So let's go back to Visual Studio here. And we're going to use the same application, but I'm going to close down a few of these windows and clean it up a little bit. So really a nice little tip here is that if you want to close, if you're working on this particular document, there's a lot of other documents open, you don't want to see them anymore. In 2005, you can right-click and you can say, close everything but this one, which is kind of nice. So I'm going to close this down. Now, one of the questions we get a lot, with modifying code, is that, well, in 2003, we didn't really provide any tools to automate the process of modifying code. About all we had was the editor. You could make changes there. Now, in 2005, we've added a set of features in C# called refactoring features. Now, I think a lot of you know what the refactoring features are, so I'm not going to go into a whole lot of depth about them, other than to say that the general idea of a refactoring is that you want to be able to change sort of the internals of your code, the structure of your code, but not change any of the external behavior, the semantics, or the external interface. And it allows you to sort of make your code easier to read, maintain, and test. Now, we have two in particular that people ask a lot of questions about, and those two are rename and extract method. The question we get a lot is, well, how do I know when I should do a rename, and how do I know when I should do an extract method? The rename one you should probably just do whenever you think the name is wrong. But we do have another way. And that way is an integration of fxcop. So if you're not familiar with fxcop is a tool you can download on the web for 2003 as well that allows you to, it's a static analysis tool that goes over the IL that's generated from your code. And it has an extensible set of rules that it can detect various violations. And of course, you can write your own rules as well. Now, in 2005, that's actually integrated into the product. And the way it's integrated is it's through project properties. So I can right-click on this and select properties. Now, again, if you haven't played around with 2005 yet, this is going to look pretty different. It's really just a different UI on top of project properties. You see at the bottom here, there's this code analysis tab. So I'm going to select this. Now, the tip here is that there's two main rule sets that are going to give you a lot of data about refactorings. And those two are naming and maintainability. And in particular, maintainability more for extract method and naming more for rename. So you can see that I have these two enabled. If I select them a bit, I can drill down into the individual rules. And I can actually switch whether or not there should be warnings or errors. So for the moment, I'm going to leave them as warnings. Now, at this point, I actually want to run these rules over my source. So I do that from the build menu. And if I go build, run code analysis on this project, it basically builds the application, and then it runs the static analysis tool over the IL that's generated. And you can see it generates me a report here in the error list. So let's go to the first warning that it's telling me. This is the first violation that I have. So it's basically a general Microsoft policy that if I'm writing a public API that I expect other people to consume, that I should have the first letter of the variable name capitalized, not lowercase. So it's telling me about that. So I want to fix that. So what I'm going to do is I'm just going to delete this. Of course, I haven't fixed any of the references yet. But you'll notice that I get a little annotation on the far right-hand side. It's this little orange marker that appears under the word. Now, you'll see those a lot when you're using 2005 and C#. They're what we call smart tags, and you could hover over it to sort of invoke it. And you'll see them whenever we think there's an operation that we can perform based on the action that you just did. But since this is a tips and tricks presentation, I'm going to talk about the key binding instead. So the key binding for this is Control Dot. Now, if you happen to be using Beta 2, the key binding is Alt-Shift-F10. We quickly discovered that despite being the same as Office, Alt-Shift-F10 is very difficult to hit. So we changed it to Control Dot, which is a much faster one. So I can just do this and hit Rename, and that'll go and it'll fix up all the references for me. Now, the interesting thing here is that I happen to have this style where I also keep, over here in Solution Explorer, my file name the same as the name as my types. And this is a common style that a lot of people use. And it's not enforced in C#, but a lot of people still follow it. But of course, in this case, I've updated my type name, and I haven't updated my file name. So what I'm going to do is I'm going to undo my change here. The tip here is that if you follow this pattern, then a good place to start your invocation instead is Solution Explorer. So let me go do that. Let me go here and hit F2 to cause a rename. And I'm going to just delete the first part. Then I'm going to hit Enter. You notice at this point, Visual Studio says, hey, I noticed that the type name you have in this file is the same thing as you're renaming. Do you want to rename that and all its references as well? If I hit yes. So now if I hit yes here, you'll notice that the code is updated as well. So that's just a good tip for keeping those things in sync. OK. Now, the second one is a particularly funny message. So this second one, I've just double-clicked on it, tells me that the line draw method has a cyclomatic complexity of 28, and you should rewrite that method to have a cyclomatic complexity of only 25. Now, so I had to look that one up. It turns out that cyclomatic complexity means the number of branches that occur within the method itself. When a method has a lot of branches, it's very difficult to reason about it because you have to understand all the possible inputs and cases that it can happen in it. This is a good indication that this is a place that you really want to do an extract method. So let's look down through this and see if we see anything that potentially would tell us about a method, that maybe there should be a method here. So we're doing some interesting things. And here we go. And this is always a very good indication that potentially there should be another method here. When you have a section of the code that has a comment on it that says, here, this is the point where I'm going to do this particular function. That's usually a good indication that maybe that thing should actually be a separate function. So, and in fact, this one's even more funny because when I wrote this code, I actually put, oh, and here's the end of it. So, and it's not actually contrived. This is code I wrote a long time ago, but not contrived. So what you can do is you can select the code all the way down to where it says the end. And what I can do is that the key binding for extract method is Control-R, Control-M. So I'm going to hit Control-R, Control-M, and forget the unsafe context thing for the moment. And I'm going to call it line clipping, since that's basically what it told me to call it. And you can see what happens is it extracts the method for me. It determines the signature. It keeps me at the call site. If I use F12, I can go and I can see sort of that it did, in fact, create the method for me. And I can go back. And it determined that all of the integer parameters that I pass in are modified later. They're used later, and they're modified within the method, so they needed to be passed by ref. So the additional tip that I want to mention here is that if you're using extract method, you should use it for code that you already have written, basically the entire method, from which you're extracting the new method. And the reason is because otherwise it's very difficult to determine the correct signature. And here's a perfect example. So if you haven't written all the code yet, there's another method that we provide for generating a more proper signature, which I'll talk about in the next section. So this is basically what I wanted to talk about with modifying code. So let's go back and just take a look at what we talked about. So modifying code. So now we have integrated static analysis. This is in the VSTS SKU. It's not in the Express SKUs. And it's just like normal FXCOP. You can extend the rules for your own company if you'd like to. In addition, we talk about some of the places where the static analysis tool can be very useful for determining where you want to perform a refactoring. And we saw the rename entry point of Solution Explorer. So the next thing we're going to talk about is tips for writing code. So let's go back here. Again, I'm going to clean up the environment a little bit. This time I'm going to use the window. There's actually, off the window menu, there's a close all documents. I'm not going to bother to save it here. And we're going to go down to the writing code demo. Now, I don't think it's reasonable to have a writing code demo that actually has any code in it to begin with. So we're going to start with a blank slate. Now, in this case, what I'm going to start by doing is typing the word class, because I want to introduce a class here. Now, for those of you that have used Visual Studio a bit and the new betas and such, you probably know about code snippets. For those of you who haven't, code snippets are basically templatized blocks of code that really make writing code significantly faster. So in this case, if you notice, if I hover over class here, it tells me that this thing is a code snippet. So what I'm going to do is I'm going to insert it. Now, when it tells you when something is a code snippet, what you need to do is you need to type the entire word, and then you hit tab after you've typed the entire word. And when you do that, you'll notice that it inserts a bit of code for me. And so in this case, I'm going to call my class program. Now, you'll notice that this thing has a funny highlight. This thing means it's a replaceable field. And that whenever I hit enter, enter will commit this field, and I won't be able to go back and sort of change it. But if there's multiple fields, I can tab between them. So in this case, I'm going to hit enter. You'll notice I'm taken to sort of the logical place in between the curly braces. And take a look at that. So here, I'm going to type SVM. SVM is another snippet that we ship. It's pretty simple. It just creates a main method. And then I love giving this next part of the demo because it irks the VB guys to no end. So the VB guys are they're on the third floor in our building. And they always, they're always funny because they always see when I give demos, I always have to type something like program P equals new program. And they're like, well, why do you have to say the type name twice? In VB, I can just do dim P is new program, and I don't have to worry about saying program twice. Well, so what we did is we went ahead and we created a snippet. And we call that snippet dim. Now, when we insert it, it does exactly what you'd expect. You can type program. You hit tab, you hit P, and I've only had to type it once. Now the really interesting part about that is that I mentioned that we created this snippet. It's not one we ship in the box, it's one we created. And since it's a tips and tricks presentation, I want to talk a little bit about that. It turns out that the snippet stuff is fully extensible. And there's two main directories you should know about. The first one is the snippets that we install by default. Now, I don't expect you guys to remember this directory off the top of your head. I'll post it later. But in general, we install these to this directory. And you can see if we search through here, if we look at class, and we drag it over to the IDE, we can see that the snippets are really just XML files. And there's a few points that are particularly interesting here. There's the first one that's called a shortcut. The shortcut is basically the thing that appears in the completion list. This is the thing that you have to type fully in the IDE before you hit tab to insert the snippet. There's some descriptive information. The next important piece is the snippet type. So there's two snippet types here. It tells me that it's an expansion and a surrounds with. Now, we didn't talk about surrounds with. The expansion is basically what we saw. You hit tab, it inserts some code. We'll get back to surrounds with in a second. Then we go down here and we get to the actual snippet portion. There's some declarations, which we'll talk about in a second, and then there's the code block. And the code block is exactly what you expect. It's the code that should be inserted. Now, in this case, the code that should be inserted has this funny thing here where it says $name $. Now, what this means is a syntax for referring to a field that's defined in the declaration section. So in this case, we're referring to the literal that's defined up here. You can see that it has an ID of name. In this case, we give it a tooltip, so when you hover over it, this will mean that this thing has a green background and it's replaceable when you type it in, and you can tab to it in the snippet. And in addition, it has a default of my class, which again we saw when we inserted the snippet. So this is how easy it is to sort of create your own snippets. Now, there's also this $N, and $selected $. $N is a special predefined literal that means put the caret location there after the user hits enter. The $selected is used for surrounds with, and it means where to put the selected text if somebody does a surround with. Let me go ahead and show that real quick. So if we go to program and we select this text, what you can do is you can hit Control-K, Control-S, and get a sort of an insertion snippet picker, and we can type class here. And you notice that the selection actually appears in between that class. So you can use this snippet for both sort of insertion, expansion, and surrounds with. Okay, so now that we've sort of seen how to create our own, I want to show another thing that we have in the IDE. Now, it really relates to the extract method that I was talking about earlier. Let's suppose that I wanted to add a method to this class, which counts the number of words in a file. Okay, so what I can do, instead of going up and defining the method, I'm going to write the call to it first. So what I'm going to do is first I'm going to create a string that is the file name. Let's say it's @c/foo.txt or something. And then I'm going to create something that returns the number of words, and off of P, call this thing count words, and pass it in the file name. Okay, so you notice that as soon as I finish typing that, I get, again, one of these little annotation that pops up, and it's telling me that based on what I just did, hey, there's some action that I can perform. Again, we can hit Control dot, and when I hit Control dot, it tells me, hey, I'm going to generate a method stub. So I'm going to hit Enter. And you notice it figures out for me the signature of what to pass in. It figures out the correct name. Actually, it figured that out from the identifier that's passed in, file name, so I don't even have to change that. And it figured out the return type. Now, this is also particularly funny. You notice here that it's throwing a system.exception. And then that system.exception says this method or operation is not yet implemented. Now, we've had a lot of feedback about that. And people say, you wrote the framework. Don't you know there's a not implemented exception? It turns out we do. But we shipped in version 1.1 of the compact framework. It doesn't actually have not implemented exception. So if we generated it when you built, you would get a build error. And we usually have a rule that any code we generate shouldn't cause a build error. So, we made the choice to use the least common denominator. But a lot of people don't write compact framework code. So the interesting thing that I want to show you is that we have not only snippets that are generated for generating code, right, but also for generated code. So we go up a directory, there's this directory called refactoring, and there's this method stub.snippet. So I'm going to drag that over here. And if we look here, we can see that this thing down here looks very similar to what we saw generated. It has the text in it that says this method or operation isn't implemented. So what I'm going to do is I'm going to delete it and actually make some changes. So now you'll notice that this $exception$ is referring, again, to a literal defined in the declaration section. Now, this literal is a little bit different. This is a code generation literal, so it's not editable, and it's based off of a function. There's only a few functions that we provide support for, but this particular function is one that you're going to find very useful when writing your own snippets. It's called simple type name, and what you do is you pass it a type name. In this case, we're passing it system.exception. And when you pass it that type name, it means that when you insert the snippet, the place where it's inserted is going to be sort of reduced to the least possible set of code that it could be. So if, for example, and I'll give a demonstration of that. So let's just make this not implemented exception now. OK, and then we can just save it. Now when we go back, I'm going to undo what I just did. And again, I get the smart tag that says, hey, you just deleted that. Why don't you add it back? I've added it. And now you see that I get system.notImplemented exception. So I fixed that, even though it's sort of a refactoring feature provided by the IDE itself. So I'm going to undo that one more time and just give a demonstration of what the simple type name does. So in this case, I'm going to do using system. Now, when I do using system, notice that when I generate this, it actually generates not implemented exception. That's because simple type name reduces it to the least possible thing it could be in that scope. So there's one more thing I want to show off about writing code. It's amazing how fast time goes with these things. I want to show off one more thing about writing code. And this is one we've gotten a lot of feedback on, too, particularly from the betas of Visual Studio 2005. So let me give an example. Let's imagine that you wanted to write a for loop. So some people, when they write their for loops, they actually don't declare the variable directly in the for loop. They want to declare it, but they want to declare it later, or, I mean, in terms of time, above the declaration that they're writing. So in this case, I want to write for I equals 0. So you notice that when I type I, the completion list appears. Now, if I were to hit space at this point, it picked int for me, but I don't want int. I want it to be I. So the most natural thing to do is go back and delete it again and type I and then space. Now, people, we've gotten feedback that if you don't, so it turns out if you don't declare the thing before you use it, it's difficult to type it currently with this system. So we have some options that make this significantly easier. So what you can do is you can go to Tools Options, and the C# text editor options are under Text Editor, C#. And in this case, we want to look at the IntelliSense options. Now, the first one, for those of you that don't like the completion list to come up quite as often, is you can basically revert to the Everett behavior. So there's this top option that says Show Completion List after characters typed. Let's uncheck that. And when we go back to code, now when we type for I, you notice the completion list didn't come up. Since the completion list didn't come up, I don't have the problem of it inserting int for me. So that's the first thing we have. So the second thing we added, and this one was added somewhat late, based on feedback that people liked the completion list coming up. They just didn't like it that space completed for them. We have options to control what the set of things are that complete a completion list are. So let's say we re-enable this. Then we notice that we have a section called Section and Completion List. What this is this is basically the list of characters that if you were to type them and there was a selection in the completion list, it would insert that selection. So the most interesting one, potentially, for a lot of cases, is this committed by pressing spacebar. So let's suppose we uncheck this and we go back to our code. Now you'll notice that when I type I, the completion list does come up, which is what we expect. And int is selected. But this time I'm going to hit space. And you notice that it doesn't insert the text because I've disabled that as a completion character. So now there's a bunch of configurability here, and you can really make it map to the way that you type. So hopefully that provides a better experience. So that's really what I wanted to talk about with writing code. Let's just review some of the stuff that we talked about. So first thing, snippets. Completely extensible. You can add your own. The second thing is modifying code generation. So even though we use snippets for our code generation as well, so you can modify those. The second thing we talked about, just IntelliSense and customizing the completion behavior. And finally, some code gen stuff. So basically just smart tags, using control dot to invoke them, and generate method stub, which really just the tip there is really that in the case where you're writing new code, use generate method stub. In the case where you're refactoring existing codes, use extract method. OK, so that's what I wanted to talk about with writing code. The final set of stuff I want to talk about is for debugging code. So let's go ahead and go back to the IDE here. And again, I'm going to clean this up a little bit so that we can use some of the stuff. One of the things that is actually a really good thing for demos and potentially useful at work as well is that you can build these configurations. in this case I'm going to select debugging code, you can build these configurations that actually build only the project that you're using. So if we go to Configuration Manager here, you can see that this particular solution configuration doesn't build these other two projects. And that means that even if I messed up the other two projects, I can still make my demo work. So let's take a look at employee and program. These are the two things that are in this debugging demo. So let's start with employee. So the first thing we notice is that this is a pretty simple employee. They have a name and a salary. If it were only that simple. Now, what you can do, it also has a constructor, which you can create an employee with, and one single method, which allows you to increase the employee's salary. Now, if we look at the program class, the program class is also pretty simple. It's just creating an employee called Anson, who has a $100 a year salary. And the second thing is that we're going to increase his salary by basically his current salary times 0.05, so a 5% increase. Now, this is debugging demo, so I'm going to start debugging. So I'm going to hit F9 to set my breakpoint here, and then F5 to start debugging. So when I hit F5, of course, it's going to build and then run and then hit the breakpoint. And now I want to see whether or not the increased salary method is doing what I expect it to do. So what I want to do is I want to step into it. Now, what do you think is going to happen when I step into this? I'm going to step into the property. Well, let me hit F11. I step into the property. I never want to step into that property. I'm using that property like a field. I never want to step into it. So I really wish there was a way to customize the debugger to tell it that I shouldn't step in there. Turns out there is. And this is a tip that's valid both in 2003 and in 2005. And you do it through attributes. So what I can do here is I can put an attribute on this called debugger step through. Now I'm just going to type it here. You notice it's not in my completion list. It's not in my completion list because I don't have the right using directive. Again, we see this little annotation pop up at the very end here. I can hit Control Dot, and it says, hey, I know this type exists in some other using. Are you just missing a using directive? So I can hit Enter here, and it'll add a using directive at the top of my file for me, but keep me in the same place. So now I can go in here, and I can hit Debugger Step Through. Now I'm going to start debugging again. So now at this point, when I hit debugging again, I'm at increased salary. I'm going to hit F11. Notice that I step into increased salary instead. I'll never step into that property anymore. Now, if I had a bit more time, I'd combine some of these things. So it turns out that since you can customize the snippets that we ship, and we ship a property snippet, you can actually customize the property snippet so that it always steps through. So anytime you generate a simple property using the property snippet, you would never have this problem anymore. So let me go ahead and stop this. Next thing I want to show is really about data, when you're viewing data in the debugger. So I'm going to delete this stuff. I created a snippet called employees. And all this does is it's basically just creating a list of employees instead of a single one to sort of demonstrate this point a little bit more. So I'm going to hit F9 here, and then I'm going to step in, or hit F5 to hit the breakpoint. And it will start debugging here after builds. I guess I didn't hit F5 correctly. So now we can see down here that we have these employees, right? And it gives us a list of them. And what do we notice first, the very first thing? Let's suppose I wanted to find out information about Luke. Well, this list only tells me that these things are employees. And if you look at this for a while, you're like, well, I know they're employees because it says so right on the right. So I really have to actually drill into these in order to find out which one is Luke. In this case, it's ordered, so it's maybe a little bit easier. But in general, that's kind of a hard problem. So what I'd really like to do is I'd like a more identifying information here that tells me what employee is in this list case. So the interesting thing, of course, the debugger can't know this information. Can't know what the most interesting bit of your code is. So what we've done instead is we've allowed you to customize the debugger to say what the most interesting part is. So we're going to stop debugging here. We're going to go to the employees class. And what we're going to do is we're going to add a toString. So here when I type override, of course, I get this completion list just like in 2003. Now, unlike 2003, if I type the return type, it actually filters down to only the list that actually has that return type in it. I hit enter. I get this. You notice, again, we get the not implemented exception. That's because we modified the code snippet. And I'm going to return a name. I'm going to hit F5 again. And if F5, I hit my breakpoint. But now when I expand my employees list, notice that I see the names of the people instead. Now, a lot of you that use debuggers quite a bit may be like, wait a minute, are you calling a method in my debugging session? I don't want that. So what you can do is instead of using toString, you can use an attribute. So let's get rid of toString here so that I can prove this does work. Let's get rid of toString. And at the very top here of my class, I'm going to use an attribute called debugger display. So debugger display takes a string as an argument. And this string is basically a specially formatted string that allows you to customize the display. Right now, if I were to just type in text, and every time I see an employee, I'd see that text. What I really want to do is I want to evaluate fields within the class. And to do that, there's a special escape sequence that you use that's braces, curly braces. So in this case, if I do curly brace, open curly brace, name, close curly brace, that means evaluate the expression in the context of this type in between these braces. So in this case, I'm going to evaluate name. And remember, I deleted the toString. So when I hit F5, again, we see the exact same thing, but I'm using an attribute instead. So now another reason to use an attribute as opposed to toString is when you don't own the source. It turns out we allow you to customize this behavior even if you don't have the source for it. And the way you do that, and in fact, I'm going to show you this. So in the My Documents directory that you have, if you go up a few directories, just in the Visual Studio 2005, you'll see a directory called Visualizers. There's a file in it called autox.cs and a DLL as well. So I'm going to drag this over, and we're going to take a look at it. Now what this is this is a bunch of the debugger display attributes that are on framework types that we ship. And what you can do is, you'll notice that in this case, we made them assembly level. Of course, you don't have the source. You can't put them directly on the type. And when you do this, there's actually a name parameter called target. And what you do is you just say the target is the type that you want the attribute to apply to. So in this case, you can see that we're basically putting the target type, right, system.type. And we're saying that anytime we see a system.type, what we really want to see in the value column of the debugger is its full name. So again, you can go ahead and modify this file all you want, and you can change the way the framework types look in your debugger as well. OK. So there's one more attribute that I want to show. I'm going to just demonstrate this problem once more by hitting F5. So let's suppose we expand these employees. OK, that's good. So now we got to the point where we can find the particular employee that we want. We find that we want to take a look at Luke, and we expand him. And what do we notice? We notice that, again, we have this problem where we have the property, which says that his name is name, and we have a field that says the exact same thing. So yeah, a lot of debugging is really finding the data you want and narrowing it down. So you don't want to look through a lot of data that's not particularly relevant. So in this case where you have properties that are basically always going to just do a simple get of the field and return them, it would be nice if there was a way to say that you didn't want to see them. Again, it turns out there is. So if we go into employee, let's go to name this time. So on name, what we can do is we can put another attribute called debugger browsable. So in this case, if I select debugger browsable, and I pass it in, it takes an enum, in this case a state. One of the options on the state is never. Now, if I hit F5 again at this point, we'll see that what happens if I expand employees and then a particular employee is that, in fact, I don't see the property anymore. And once again, you can combine the stuff that we've talked about and put this on the property snippet so that if you're ever doing simple properties, you can see that you actually only ever see the field backing and you don't see the property itself. Now, of course, if you explicitly evaluate the property through the immediate window or whatever, we still evaluate it and show you the result. So that's a quick tip about, really, there's a bunch of tips about modifying the display of things. It turns out that there's a few more attributes that are more in depth that we won't have time to go into. In particular, there's one that allows you to create a visualizer, which is basically a separate window that you can do if your type, for example, has its view is very different from what it would look like in its internal implementation. And the canonical example there is dataset. But we don't have time to show that at the moment, but it's called Debugger Visualizer. So it's a good place to start reading about it. So the one last thing I want to show is that in 2005, if you haven't used it yet, one of the things that we did is we made our data tips a bit more useful. So it used to be that data tips would show you a lot of good information for primitive types. But since they weren't expandable, you couldn't actually see any more information about sort of more complicated types. Well, now in 2005, I can actually hover over this plus, and I can drill in directly in the editor. So I don't have to go to the locals or watch window anymore. Now, again, since this is a tips and tricks presentation, one of the things that happens is when you navigate down a bit, particularly deeply into these nested hierarchies, you get a lot of these things. You lose all the code. You can't see your code anymore. So what you can do is you can hold down the control key. Watch this. You can hold down the control key, and it disappears. So there you go. That's a quick tip there. All right. So real briefly, what we talked about sort of debugger customization. So a lot of the debugger customization is done through attributes. There's several attributes that allow you to control it. In particular, we looked at these ones. Again, there's also two other attributes we didn't talk about called debugger type proxy and debugger visualizer. In addition, we saw control makes data types invisible. And that's basically the end here. So what I want to do is I want to just point out, I'm part of the C# team. One of the major initiatives the C# team is talking about at PDC is sort of the link stuff. So a lot of the other presentations we have aren't tips and tricks. They're on the link stuff. Some of them have already happened, but there's many more that are still going to happen. In particular, right after this session, there's a D-Link presentation. So if you're interested in link, I suggest you go to that one. I will be at Ask the Experts this evening, so if you guys want to learn more tips, you want to come talk about some stuff you found in the IDE, feel free to meet me there. Thank you. One additional thing before you guys all leave. It's just, I know we went through this really fast. There's a lot of keyboard bindings that I said, a lot of tips and tricks. They're not reflected in the slide deck. I'm going to post them on my blog. So if you want to write down one thing from this presentation, write down that link. And also fill out your session evaluations if you find time. Thanks a lot, guys.